Welcome to Passive House Accelerator's fifth Global Passive House Happy Hour of our second year running and episode number 57. Thanks for joining us. I'm Prudence Ferreira. I'm a senior member of the Carbon Neutral Design Group at BR Plus A Consulting Engineers, and I lead their Passive House team. And no matter what the reason is why you showed up tonight, whether it's to see your buddies or nerd out on passive house and building science, or you're just curious and have never been here before, you are in the right place. This is the happening spot on Wednesday nights. We're going to learn about some really fantastic stuff tonight. We have a great show, or this morning, or whatever time of day it is where you're at. But first, I just want to mention a big victory for all of us. Yesterday here in the US was a fantastic day for justice when police officer Derek Chauvin was convicted of murder for killing George Floyd with a swift verdict. And I'd like to invite you all to unmute yourselves and join me in a somber but also celebratory toast to justice.
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 Justice for all.
Justice.
Justice,
The work
justice,
ahead.
justice.
Yep.
Progress and work ahead.
The equity
There
work
is.
begins.
To accountability, not justice. Accountability.
Amen.
Yeah,
Well
I
said,
agree.
Talia. Thank you.
Yeah.
Yeah.
About guns not being the first alternative.
Yeah.
Thank you, everyone. So mute yourselves and settle in. And, I agree that that verdict was really just a start in one area where we need a lot of work. But in order to deliver real change and reform, we have to do more. And racial justice and equity and climate justice are very much intertwined. And as a prelude to our policy summit coming up, I'd like to invite you all to start thinking about how the root of climate justice is power sharing and decision making, and how you all as concerned citizens with technical expertise or just passion might engage more directly in listening to the underserved communities that are in your region and thinking about how you can help support them with your knowledge and passion. We've got another great show. We have Ryan Lobello and Louis Koehl of Handel Architects here to talk about Sendero Verde, a groundbreaking example of equitable access to healthy and sustainable building in East Harlem. It was developed by Jonathan Rose Companies to be a community of opportunity that includes 709 units of affordable housing, a school, a community garden, community center, medical offices, and more. But first, over to Zach.
Right. Thank you, Prudence. And thank you for that introduction. It has been a really important last 24 hours. So I'm going to move to something less important, but also personally exciting for the Accelerator, and that's the new website. So I just wanted to do a quick orientation to this website. And before I do, I want to thank Sydney Gladu of the Accelerator for all of her work on this project, as well as Matt Rothenberg, who has developed the website. I want to do a quick orientation and show you ways that you can add content to it real fast, and then we'll move into the heart of the program. Okay, so this is the current website version of the new website. We're actually going to do some significant changes to the homepage, and which I'll share at the end of this little presentation. But you can get just a sense of what we're offering here. I want to focus first on the new section that are a series of passive house explainer pages. And all of the graphics that are on these pages are available for all of you to use with just in a Creative Commons way. Just if you could link to the Passive House Accelerator if it's on your website, or mention the Passive House Accelerator somewhere in a presentation. That's awesome. So we talk about the basics of Passive House and the why, what, and how on here, as well as the relationship between Passive House and zero carbon building. And we've got a bunch of graphics about the benefits of Passive House that you're free to use in your work. And you can see them here. And then you can go on to the Passive House, about the standards and certifications here. And of course, Passive House Institute and FIES both have different certifications. 3 performance targets here, and we link out to PHI and FIES for the details so that we know that they're as up to date as possible. And then the how, which goes into a primer on the building science behind Passive House, and these top 5 principles, the classic 5 principles of Passive House design are on the top. And then we also have 5 runners up for the 6th principle along the bottom. And we're looking at the heat, air, moisture, and sunlight implications of each of these moves. So continuously, these will all be familiar to many of you. If you're new to Passive House, this is we hope this will be a good resource for you to learn a little bit more about the moves that we make in Passive House design to create all the benefits of Passive House. So again, all of these, you can feel free to use these images with attribution to the accelerator in your work. Okay, so that's the kind of the big new piece in terms of content. You can still, of course, find the happy hour, the construction tech, and the summits here, and the community calendar under events. And just a note that once you get the link for the happy hour or construction tech, it won't change, or at least not in the foreseeable future. So you don't actually have to re-register every week to attend Tuesday and Wednesday. The only registration that's really required is for the summits, which is a unique registration. So I just want to call that out. Once you get the Zoom link for either the happy hour or construction tech, you're good to go in the future. Okay, so then we also have articles that are filterable easily by category. So you can look at, say, all affordable housing articles that have been published on the accelerator so far. And you can submit an article for review and publication and possibly editing before publication here. So it goes to a submission form, and we're looking for new perspectives and writing. So we hope that you'll consider submitting an article of your own. And that this is also true for videos, and you can submit a video. You can also sort for all Construction Tech Tuesday videos, for example, or all videos about a certain topic, building types, big picture, all this stuff. And then we've got directories, and I would encourage everybody to join these directories. We actually don't have the join button yet, but we will have soon. We've got people directories here. So particularly for people who have presented. Right now, it's mainly people who have presented or written an article for the accelerator, but you're free to submit your own listing on this directory. We also have one for service providers. You can add your business. And those are both free. The manufacturer's directory, there is a fee and a missing button, but we'll get that. Our philosophy with the launch of this website was to launch it as soon as it's as good or better than the existing website, and so we're to that point. And then I guess that real fast, I'll share the new concept for the homepage, and then it's time for us to go into breakout rooms. So the homepage will feature the relationship between Passive House and climate action, and the understanding that you start with Passive House, and we're also looking at embodied carbon, electrifying everything, and clean energy. And then we go into the events that we can attend, and then you can explore all these different categories, the most recent stuff that's been published, and then network through these directories, and of course the Q&A community. So if you have any comments as you or you find stuff that's broken, please let us know at info@passivehouseaccelerator.com so that we can keep stuff up to date.
Our featured guests this episode, I think Sean started introducing them already, Ryan Lobello and Louis Koehl. Both are certified passive house designers at Handel Architects. And Ryan is a senior associate, and his work has been focused on sustainability and high-rises, really high-rise residential projects lately, including serving as the project architect at Cornell Tech's Passive House Residential Tower, the house, and currently serving as the project architect for Sendero Verde, the 709 unit behemoth of goodness in New York City. And then Louis is functioning as project architect on Sendero Verde. Actually, no, he's focusing on administering construction on Sendero Verde, but also has experience working on the University of Toronto Scarborough Passive House, doing the detailing for the exterior wall, fun stuff. And so together, what they are going to share with us tonight is pretty exciting. It's not just about Sendero Verde, but a comparison to 3 other passive house designs they've worked on. The house at Cornell Tech, University of Toronto Scarborough, and the Winthrop Center in Boston. Thank you, gentlemen, so much for joining us.
All right. I see a lot of friends out there. Yesterday, Zach told me that I talk too fast, so I'm going to try and slow it down a little bit to make sure I'm heard and intelligible.
I don't think I said too fast. I was admiring how fast you speak.
I want to make sure the content is heard. So, I'm Ryan Lobello. I'm joined by my colleague, Louis Koehl. You've seen some of our passive house projects before. I know Deborah Molis presented UTSC earlier, probably tail end of last year. Today, we're going to quickly compare and contrast 4 passive house projects in the office, really to highlight that there's no one way, one method to making a passive house. But first, why are we here? It's because climate change is the greatest challenge to our long-term survival on this planet. A lot of attention goes to 40% of the world population at risk due to rising sea levels, but we cannot forget about the worldwide droughts, wildfires, deadly flash floods, crop devastation, access to drinking water, it goes on and on. We are already experiencing these effects, and soon the situation will be unrecognizable. At Handel Architects, we believe that passive house can be one of our best strategies to mitigating climate change. And we believe that working in cities is one of the best places to make that large catalyst and that large change. It's where you get your biggest bang for your buck. Passive houses are great everywhere, but we can affect the most people per square foot, obviously, in the Carless urban average, and that's where our work at Handel Architects, that's where we focus. And just a reminder, we know that passive houses are well suited to multi-story large buildings, and it's because of this low surface to volume ratio. A single apartment with 1 facade for 2 people is much easier to achieve on a per square foot basis than a single family home for 2 people that has 6 surfaces. And then you'll see in a second, this is the plan of the Cornell Tech Tower. Note the smoothness of the building shape, not a lot of ins and outs and articulations. Obviously, that's to decrease the number of thermal bridges. Now, at Handel Architects, we like passive house because it is a performance-based standard, and it allows us great flexibility to meet varied program requirements, budgets, and client goals. We're going to look at these 4 projects. It's the house at Cornell Tech over here on the left. It's a public-private partnership between Cornell Tech University, Hudson Companies, and the related companies, and it was completed in 2017. Sendero Verde here in New York City. It's 100% affordable housing multi-building project with Jonathan Rose Companies, L&M Development, and the Acacia Network. Also a partnership with New York City's Housing Preservation Development, a city agency. It is currently under construction in East Harlem. Over here is Winthrop Center, a very large mixed-use tower by Millennium Partners, currently under construction in Boston. And then University of Toronto at Scarborough, it's a dormitory, a public-private partnership between Fengate and the University of Toronto. The project is in the very beginning stages of construction. I was the project architect for the house at Cornell Tech. When it was completed, it was the world's tallest and largest. These things tend to come and go really quickly, as you know. Louis and I worked on Cornell Tech together. And then I was also an internal advisor on the Winthrop Tower. And then Louis was focusing on UTSC's facade. So here are the 4 projects, just a you know, this kind of a dumb idea, but the passive house, you can see here how flexible that standard is. You know, the kind of building type, the scale, the materiality, they're all different. A couple things just to pull out. You have the house at Cornell Tech here. It's 26 floors, 270,000 square feet. It's not a dorm, it's actually graduate student housing. It has about 500 beds. Now, comparing that to University of Toronto, that's 9 stories, 270,000 square feet, actually the same area as the house at Cornell Tech, but it's a lot more dense. It's an undergraduate dorm and has 750 beds. Sendero Verde, here's the 100% affordable housing project, the tower that is 37 floors, and then 2 lower rise, 16 and 10. And then there's a real robust nonprofit base, community facility base to engage with the city. Winthrop Center is a 1.8 million square foot mixed use project, of which from floors 3 through 20, 3 through 30 here are 735,000 square foot commercial office space, which, you know, it's just a portion of the building, but you kind of look at that and you're like, wow, that's the portion that's being passive house. And it's like twice the size of Cornell Tech and University of Toronto, and almost the entire area of all of Sendero Verde. I'm not going to go through all of this. We don't have a tremendous amount of time, but, you know, a couple of project challenges. Obviously, the Cornell Tech, that was the first time that we did a passive house, and it was also, you know, we're specialists in high-rise buildings, but we had to apply the passive house requirements to the large scale. So that was a project challenge. We had some code conflicts on Cornell Tech, mainly on the mechanical side, but we were able to get exceptions from the building code department, and those are things that other architects, other developers have been able to use, and now they're no longer problems in the city. Supply chain, you'll see here, I circled it in each project. Each project supply chain has always been an issue. And supply chain on Cornell Tech, obviously it was at that scale at that time, and there's a lot of issues getting certain materials. But over time, while supply chain is still an issue, it's getting better and better. Like the same way that like codes are increasing and architects, we're all asking for more products from manufacturers. They're rising. The market is rising to meet that demand, which is fantastic. The other thing I'll just point out is that these are incredibly dense buildings. You know, your source EOI target needs adjusting. What was great about Cornell Tech is that we started getting data from that, and we're able to start adjusting the density, the EOI targets on other projects based on like real world data. And then one thing just to note, this, you know, as an office building, even in Boston, it's cooling demand driven, even in that climate zone. Here's some plan examples, comparisons. You can see our original design budget here was 38.1 kilobtu's per square foot per year. And that was the same when we got to Sendero A, but then by the time we started working on Sendero B, like the density calculator started to kick in, and we were able to start adjusting for how dense, how many refrigerators, how many people are being packed into this space. I'll also point out like the density on Winthrop Center, like it's kind of weird. It's like half density in a way, because like from 9 o'clock in the morning till 6 o'clock, it's incredibly dense, and then everyone kind of goes away. So we put the people per square feet in here so you can see what that is. And obviously once you get up to University of Toronto, you're in climate zone 6, so the energy budget increased there as well. And then just a quick section study here, so you can see how the passive house standard allows for different certifying pathways. Cornell, the whole building is certified. The entire exterior wall is the airtight boundary. On Sendero Verde, the affordable housing is the certified areas, but the entire building is enclosed by the airtight envelope. The community facility spaces have been pulled out of the certifying boundary, but they still have an airtight facade. That's because tenants are community facilities, they're nonprofits. They may not have the budget initially to meet passive house, but we want to allow them that choice to opt in. On Winthrop Center, the office component is the Passive House certified and airtight layer boundary. And then there are some discussions to include the entry lobby as part of that certifying boundary, but this is now out, so I need to update the slide. And then UTSC's very similar strategy to Cornell Tech, with the exception that we pulled out a loading dock area. But being an undergraduate dorm, I just want to point out there's a dining hall here, and so you start having conversations about reducing energy use. You start saying, hey, can we go meatless Mondays, or you start talking to the vendors and be like, okay, you can have one walk but not two. Those are the types of conversations that we end up having in programming phase. So with that, I'm going to turn it over to Louis to talk about the facade.
Yeah, thanks, Ryan. I'm Louis Koehl, Handel Architects. I've been working with Ryan for many years now on many of these projects. So the facade is obviously a critical part of any passive house. So we're going to talk a little bit about some of the challenges we met here. So what we like about looking at all these projects together is you can kind of see that there's five different facades for 4 different buildings. So a lot of different ways to get to the goal. We say 5 because Sendero Verde actually has 2 different facade systems. We're using a masonry cavity wall for the tower for building A, and then there's an EFIS facade for the shorter buildings. So at the house at Cornell Tech, we had a mega panel rain screen, shop fabricated, shipped to the site, hung from the slab like a curtain wall, these big panels that are 30 feet long, 10 feet wide. I mentioned Sendero. At Winthrop, we have a curtain wall, which was an interesting challenge. And then at the triple glazed curtain wall, all these projects have triple glazed windows and curtain wall. University of Toronto is a stick built rain screen. You can see all of them, at least the 2 New York projects have an R value in the walls around R20. In Boston, because of the different occupancy and different climate zone, we're landing around R18, and then it's a little bit more well insulated in Toronto because it's in that climate zone 6. With Cornell being our first passive house, windows, as Mariah mentioned, supply chain was a challenge. Windows were a significant challenge on this project. We managed to get to a 0.18, which was, very, very impressive for that time. On Sendero and University of Toronto, we're managing to get a little bit lower by using UPVC windows. And then obviously the curtain wall is its own unique challenge there in Boston. You can go to the next one there, right? So we'll take a look at some of the wall sections here and just won't dive too deep into this, but starting over there on the left, you got Cornell Tech. You can see the panel joint there between the mega panels. And then next to that, you have Sendero Verde A. And then all the way on the right, I'll call it University of Toronto. So all 3 of these use steel studs as kind of the backup system for the structural system for the wall. And those steel studs are infilled with mineral wool insulation, and then they have mineral wools in the cavities in the kind of rain screen system or in the brick cavity. So it's kind of similar logic, but different aesthetic. Obviously different challenges with the brick. You had the shelf angle, and with UTSC and Sendero Verde, you have the slab penetrating that steel stud layer. Sendero B, we used EFIS, which is a challenging material aesthetically, but thermally it's fantastic. There's no penetrations, no metal attachments. You can actually extend it over the windows, which you can kind of see we're doing there, which helps improve your window install details. So you can see really this is the one section here where you don't have any interior insulation because it is so efficient on the exterior. It's 4 to 6 inches of EPS versus 9 to 12 inches of mineral wool everywhere else. Winthrop Center, we have heavily insulated spandrels, and both vertically and horizontally, and then a little bit of additional insulation on the inside of that. You see 2 control layers here. The blue line is our air barrier, and the green line is a vapor control layer, controlling moisture because of having the insulation on the inside of that air barrier. In all of these projects, the passive house airtight layer is that blue line, with the exception of Cornell. And that's primarily because of that panel joint. So go ahead to the next slide. We see these panels being craned into place here. This is a wet joint system. So we couldn't seal the building up until all the panels were installed, which obviously made it very difficult to test any portion of the building and make sure that we were doing this correctly. So that was a big reason why we put the airtight layer on that interior layer, because it wasn't inside the panel. So if you go to the next slide, So we could actually see the layer and access it, make any repairs that were needed. We could seal everything up around the anchors as each panel was installed, and then we could do guarded blower door tests on individual floors or sections of the building to make sure that everything was going along as planned and there weren't any surprises at the end of the project. Go next. So another thing, obviously another challenge that you deal with on all passive house is thermal bridging. This is just a kind of a smattering of some unique details that we looked at here. On the left there, you have a structural thermal break between a steel canopy. We're using kind of these similar structural thermal breaks up on the top two on the right there, where we have shook isocorbs below concrete curbs underneath the generator, and then general plastics below steel dunnage for our PV array. Next to that on the left there is our shelf angle detail. You can see we just barely make out the shim there. So it's we're using an Armatherm FR shim, which is just a thermal shim. It's 3/4 of an inch to an inch. We looked at standoff shelf angles and other systems, but this was the kind of most cost-effective conventional practice. You know, we weren't throwing the masons through a loop here. We were trying to get something that they knew how to construct, and this got us to our performance targets, you know, with really high performing windows and additional insulation in the walls. And then down on the lower right there, this is a good one that we are using everywhere now on all of our projects. We're trying to get into all of our projects. We're using 2 courses of AAC block at the bottom of all of our parapets. We also use it to support brick when the brick is at grade. And that, because that AAC block is less thermally conductive, it creates a thermal break, and you no longer have to wrap your parapet in insulation. It makes the waterproofing easier. It's cheaper, and it works within a CMU module. So you can, you know, the masons can throw that thing together just like they would a typical parapet wall. So you can go next. So Ryan mentioned supply chain challenges. One of the big, you know, this is just a good anecdote. On Cornell there on the left, we had a condenser porch on every floor, and we really struggled finding a thermally broken door to access that porch. And so there just wasn't a good thermally broken door on the market at that time. So what the team ended up doing is using like a deli door, like a big refrigerator door, which gave us an R28. So plenty of insulation, but obviously not the most conventional detail, and much more expensive than a typical door. Over on the right there, you see once we got to Sendero, the market had adapted, and now there is a thermally broken hollow metal door and frame on the market. You know, we only need that R2.5. It's not a huge difference from. It definitely doesn't need to get to that R28, but just that little bit. You know, when we work through the installation details, we can make that work with our model. Go next. And then the last thing that we are starting to consider with Sendero Verde and other projects, we're really trying to start to think about embodied carbon and how that plays into our projects. It's not a passive house requirement, but it's, you know, something that as we build more and more insulated buildings, you know, we get more and more refrigerant in our buildings. We need to start thinking about how these materials impact, you know, the embodied carbon of our buildings. So one thing that we committed to is trying to use mineral wool insulation wherever possible, because there is, you know, XPS insulation has such a high carbon emissions. So we used XPS nowhere except for foundation walls where it's kind of required. With the EFIS system, we really pushed to get a mineral wool system. The market didn't quite get there. We weren't able to use a mineral wool EFIS system, which exists in Europe and Canada, but doesn't exist in the US market. Stowe has since introduced one, but not in time to get on this job. So we used EPS. So we sacrificed a few points on our R value to save some carbon emissions. And then of course, we're all looking forward to the day when we can grow our own insulation there with the mycelium. You know, hopefully that'll be in all our projects one of these days.
And so here we are, a robust facade and efficient and balanced heating and cooling with energy recovery. And what we've just done is reduce the energy use in our building from 130 EUI, that's based on a 2018 New York City standard, down to about 38 to 50 EUI, depending upon your density. But also notice what happens to the slices of the pie. Before we were spending almost 50% of a much larger pie on heating and cooling. Now we are only spending 10% of a much smaller pie on heating and cooling. So for for us, it like begs the question, what is the next lower hanging fruit? So we're starting to focus on domestic hot water demand, lighting, plug loads, and like Louis mentioned, the embodied carbon. And the work is happening. Here are some construction images of the Sendero Verde project. You know, you have building B North and B South, they both topped out. B South is just starting to receive its EFIS finish coats, and it's about a year left until residents can start moving in. Building A is this site over here in the corner. We're just closing this phase in June, and construction is slated to start in September. And at the end, you get a beautiful building. Your client is happy, and you're saving the earth. But don't forget about a couple other important reasons why we like Passive House as a main strategy towards green building. And that's because Passive House can enhance the occupants' lives. There's an acoustical quality, a quietness to the space. The interior and the exterior is air sealed and insulated. This is the Queensboro Bridge in the background of this image here. That's eye level with some of our units. Our 15th floor is eye level with Queensboro Bridge. That's rush hour traffic twice a day. Just imagine the noise. New Yorkers like to honk their horns. And it just, when you shut those windows, you don't hear anything. And it's so like Passive House is ideal for these noisy and urban environments. And what it allows, it's this quietness that's important for mental health. It's about, Passive House is about a comfortable temperature and thermal criteria, options for control. Of course, we can open our windows. It's about low cost for heating and cooling. In a conventional building, air conditioning may cost upwards of $150 a month in New York City. Now, what if that cost is reduced down to $10 or $15? Well, that choice is a lot easier and can really impact people's lives. And for us, this really starts to speak to equity in green building. And just to reiterate, we are also providing healthy filtered fresh air 24/7. This increase of interest in health and wellness is a main driver that we're seeing not only with our clients, but one of the main places we are seeing concern for green design concepts starting to percolate into the general population, affecting marketing and leasing too. And just to conclude, at Handel Architects, obviously you could tell by the talk, we feel Passive House is one of the best strategies we have to protect this house. Thank you.
All right, that was fantastic, guys. That's like, not only was that total like spot on, but for anyone who's doing Passive House consulting, that's the way to put together a pitch deck, man. Like that's how you do it. Right on, guys. Thank you. So we're going to start with some general questions, concierge by Sean, and then you guys going to hang out with us for the after hour?
I can hang out like half of that, but then I got to leave at 8:30 my time.
How about you,
Yeah,
Louis?
same here. Yeah,
Right
I
on.
got to head out at 8:30.
We'll take whatever you can give us. All right.
Excellent. So we have Harvey who asked a question, and I think the answer is kind of carried on, but I think you really want to be first in the queue. So Harvey, did your question get answered?
Well, I think it did. I just want to congratulate you guys. That was a fabulous presentation. And I think as good as it was at the beginning and the middle, the end was phenomenal, Ryan. Way to close. It really was that you hit it. And my question is, what were the lessons learned that you can pass on to us and to your next projects? That was all. I think you've answered some of them, but if there's any talking about low-hanging fruit, what would they be for us as our takeaways? And thank you.
One of the things, and it was interesting, Zach was showing the new Accelerator website. In the very front, it's talking about energy use and reducing carbon emissions. But like what we're finding is that indoor air quality and kind of the health benefits are something that a lot of people are actually responding to more now. That may be different in 10 years from now. But as a way to like, pitch this and as a way to get clients on board, like we've started emphasizing that. And so I think, as a gateway that Passive House Accelerator is, that's one lesson learned like there. Like let's make that front and center so we can direct people there and they see that although it's not a requirement technically for a certification, it is a very significant benefit. And let's put that there for all of them to see. Some of these materials that Louis was talking about, and we have some more that we can go over that didn't make the final cut into the presentation, but we're using passive house projects, our passive house projects to use these materials, and we're finding some which are cost neutral or very moderately if there is a increase, that we're using them all over the place now. Like the AAC block, that's not just for passive house projects, that's for all of our projects. And as codes are increasing, our business as usual is getting more strict as well and needs those type of products. So I would describe that as one. And Louis, I don't know if you want to talk about a few of these. You mentioned the shook and the general plastics in the presentation. I don't know if you want
I
to
think,
talk a little more.
I mean, in general, these are probably pretty familiar to most. I mean, thermally broken clips. We are using a Cascadia clip on UTSC. Insulated CMU block, we should probably remove. We're not really using that much anymore because of the AAC. Gaskets, warm edge spacers. I mean, these are things you're starting to see in every project. Mineral wool back defis. I think that's a lesson learned, that, just really push vendors. I mean, bring it up with vendors, especially on large projects like this, where you have, the project's going to go on for a few years. I mean, when we first started talking about mineral wool ethos with this representative from Stowe, I mean, it was kind of like, it's never going to happen in America. And by the time we were buying out the job, he was, give us a couple more months, it'll be on the market. So I think there is people are excited about, and they're seeing what the future holds with new building codes. And vendors are interested to hear from us. I mean, we talked to Mitsubishi. There's a lot of different vendors that we've spoken to and are very interested in getting technologies and products that meet the needs of passive house and what we think will become the future of building codes.
Yeah, I just add to the dynamic glass on some of our highly sustainable projects with really good budgets. We're getting dynamic glass in there as well. That's allowing us to increase our window wall ratio. The pozzolan concrete is really speaking more towards the embodied carbon. And then last, this is the Cascadia clip that Louis mentioned. We're using this type, or like a green girt. This is not just for passive house projects. This is for everything. So that's kind of reinforcing, like, the stuff that we're working with right now are things that the entire industry is going to be working with in 5 years.
You hope to see then some significant price decreases then if you had to build this, irrespective of lumber, but and other price increases.
Oh, don't talk to me about lumber, Harvey.
Okay, I won't. So that thing that Mark, who's a T-stud that talks about all the time, that thing. But other than that,
because right now lumber prices are through the roof and causing all kinds of problems on all kinds of projects.
No, I recognize that, but are you starting to see from the beginning of this to now, and then looking out in the future, that a lot of the products that you're showing, plus your suppliers, are you starting to see some drop in price because we're seeing some economies of scale?
Yes, absolutely. Like the general plastics block that we bought for Cornell Tech, we're actually using Armatherm blocks in similar applications, and they're cheaper. There are more manufacturers in the marketplace, and the price is dropping.
Great, thanks so much, guys.
Thanks.
I think it's also a familiarity with, in terms of cost, I think it's also a familiarity with the labor. I think as particularly things like masonry, I mean, as masons become more and more aware of things like standoff shelf angles and thermal shims, and they get a little less scared by seeing that in a drawing, and you don't get that upcharge on the labor end of things. It's just another way in which things get cheaper.
Can you guys, sorry, good questions there. Can you guys go to the last slide where you show the earth and it says protect our house? Because I'm hoping that everyone will take a screenshot of this and post this tomorrow on Earth Day and give you guys some love, because again, it's a good recognition of.
Well, if you're doing that, I'm gonna go full screen on this baby.
Thank you.
Perfect. Yeah, do it. Do it.
Perfect. Patrick, I see your hand up. We'll get to it in a second here, but I want to make sure I got this. So unfortunately, the Sendero household is now busy with activities. So I am going to jump off, and Jay is going to take over as the question card shares. Ryan, Louis, thank you very much. I will definitely be posting this picture, and hopefully everybody has a great Earth Day. And the next person in the queue is Beth, and Jay will manage the rest.
Thank you, Sean.
Thanks, Sean.
Great, thanks. Just wanted to kind of stay on that theme of the learnings. So when you talk about EUI and applying to subsequent projects, when I think about everything you guys put on the list of, your targets in terms of performance, from EUI to indoor air quality to sound performance, did you specifically take key learnings or metrics as you learned and developed them from Cornell Tech and then apply them to your subsequent projects? And if so, how did you do that, and how did you kind of gain a sense of what you might be able to shoot for or strive for, either better or worse, because of what you learned at Cornell Tech?
Yeah, I mean, post-occupancy evaluation is incredibly important, particularly in a project like Cornell Tech. And so we knew that going in, and that it was kind of a laboratory to see what the energy use is. But we also know that you can't control everybody. There are a lot of refrigerators in there. There are a lot of computers in there. It's a tech college. And you can't control how people use it's a home. You can't control user plug loads a lot. And so we did a lot of things to kind of be proactive, where we, some of them are kind of corny, like we have a touchscreen TV in the elevator lobby that is measuring the energy use per floor, and kind of like shaming the floors that are doing poorly and rewarding the floors that are doing better with like a pizza party once a month. But obviously that's not, like, some people are not motivated by things like that, but we were able to identify, hey, there's a lot of energy use happening on this floor. Why is that? And upon further investigation, just to prove that you can't control anything, once you build the building and people move in, they're going to do what they do. There's like a guy running a Bitcoin server farm in one of his units. Like, obviously that's going to take a lot of energy, and he's paying for that energy, but like it was throwing all of our numbers off. So like we are actively monitoring the energy use in that project, and so was Stephen Winters Associates, so was Burrow Happel, the MEP engineer, as well as PHI, and the data and the information that they are garnering from Cornell Tech, as well as other large multifamily passive houses, is what led them to the density calculator. And it makes a lot of sense when you're cramming how many people and how many families and how many households into a floor plate, that there should be some increase in the allowable EUI. And so you can see, I'll just go back to that slide for a quick second, but you can see when we were, we set up a system, but we weren't the ones like monitoring it to change. Where is it? Here it is. We weren't the ones monitoring it. It was really PHI that came down and said, okay, they said they're monitoring it so they could give us updated information on density. But that happened between when we initially designed building A and when we designed building B. And then all of a sudden that number increased. And they're still monitoring it. So like these projects are also going to go through a post-occupancy evaluation. This, University of Toronto as well, like they're monitoring these projects so they can continue fine tune. Maybe they made it too lenient. Well, they're gonna figure it out the next time. Like passive house on any project, these are all working buildings. They're things that the agency is looking at and refining their requirements.
Yeah, and I think just one more thing to add to the density calculator. When we first started Sendero Verde, you can see building A there, excuse me, building A there was targeting 38.1, that classic passive house number, because when we started that, the density calculator had not been, put into place by PHI. So there were certain things certain challenges that we were trying to meet there. I mean, for example, we have tenants down in the bottom of the building. It makes perfect sense for those tenants to share the hot water from our base building, but that would increase the pump energy. That would push us over that threshold. So there's certain efficiencies and also just like simplifying the maintaining of the building, decisions that you might make that actually are challenged by that 38.1 that may make it worthwhile to increase that EUI to ultimately, make the maintenance a little more simple so that it's run correctly, and kind of, so there's certain, and it's just interesting to think that it's not all just about keeping that energy number low. There's a lot more to it than that. So that density calculator helps to kind of make the building run more smoothly.
Yeah, and sharing BTUs across different programs, like it facilitates that a little easier.
Hey, Ryan, we have a request for you to bring up the wall assembly details.
Ooh, fellow nerds unite.
Don't look too closely. These are graphics made by our marketing department, so
yeah, but
some of the lines might extend into places that
some
they
stuff
shouldn't.
that's a little funky, but it's pretty good. The one that was tricky for me is the triple glazed curtain wall on Winthrop. Like this needs to be a vented light. Otherwise it would get too hot. You start to have glass popping and distortion displacement. And so like our air boundary actually had to go along the backspan. It was very interesting detail, but since it's all made in the shop, it was achievable. And in terms of supply chain for that Winthrop project, that was a real challenge. There are a number of manufacturers in North America who make triple glazed curtain wall, but not at the scale that we needed for a 1.8 million square foot tower. And so it was a challenge to identify the manufacturer on this project.
Who'd you go with?
I have my cheat sheet here because I'm no longer on that project. I'd have to look. Give me a second, I'll find it and I'll let you know a little later.
Want to thank our sponsors. None of this happens without the support of these sponsors. And I just want to take a quick moment to note that and welcome Rockwool as a founding sponsor. Our founding sponsors are the major sponsors to the Accelerator who make it all happen, who joined us during the foundation of the platform. So they're really the organizations that have helped make this happen and have provided the launch pad for us to survive and thrive. And with the addition of Rockwool as a founding sponsor, we're closing now the circle of founding sponsors who will continue to sustain us. And I just want to give a special shout out to all of them tonight. Our founding sponsors are 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwool North America, Stillcorp, and Zola Windows. Our stakeholder partner is NYSERDA. And our patron sponsors are Aero Barrier, BR+A Consulting Engineers, Brennan Air Tightness and Insulation, Inotech Windows and Doors, and US Engineered Wood Teestead. So thank you to all of our sponsors.